Hey everybody, this is Mr. Ainsworth. Let's greet each other properly. Good morning. Hey, listen, we're going to get into another lesson on how to graph parabolas here, and we're going to take a look at a special family of functions of the parabola called y equals ax squared. And what we're going to do is we're going to take a look at what happens to the effects of the function after changing the values of a, which is called the lead coefficient. So, when a is 1, we call that the parent, okay? So what happens to the offspring, the functions that mimic or resemble the parent function? What happens to them as we change the value of a from 1 to 1 half? Down here, we're going to change it to 2. What happens as it gets bigger? What happens as it gets smaller? That's the whole goal of the lesson. We want to figure out how does a affect the function, okay, the parent function y equals x squared. And then later on, we'll figure out, what the effects of H are and what K are, and we'll talk about something called vertex form in future lessons. So this is one of a series of lessons. We're going to take a look at what happens as you change the value of A. Now, we're going to call the parent function y equals x squared where A is 1. Why do you say that? Well, there's a 1 x squared right here, right? So A equals 1, we call that the parent function. The other guys are called the offspring because they look like this, but they're slightly changed, right? Just like you look like your parents, or not you're exactly the same, but you look like them in some respects. All right, you resemble them. All right, just like that, these functions here resemble the parent. So if we learn from the parent, well, then we could figure out the offspring pretty easily. Okay, so what we're going to do is we're going to take a look at the parent function. We're going to take a look at the domain here, which is a set of x values. And we're going to take a look at the range, which is a set of y values. And then we're going to use those values and plot the function. We're going to take a domain from -3 to 3. Oops. -3 to 3, -3, -2, -1, 0, 1, 2, and 3. We're going to substitute these values into the function, and then we're going to plot these points and learn from them. Okay, and then we're going to verify everything we do on the T84, which is your graphing calculator, which you should have off to the side. Okay, here we go. When we take a look at y equals x squared, we're going to take a look at all the numbers squared. So what we do is we take -3 squared, which means -3 times -3 or +9. So we're going to go left 3 up 9. So let's do that. So left 3, this is -1, -2, -3, -4, -5, and so on. We're going to go left 3 up 9. 1, 2, 3, 4, 5, 6, 7, 8, and approximate the ninth place. Right there. There's -3, 9. Let's plot -2. So what happens when x is -2? So you need to substitute in here, just like wherever you see x, and then square it, right? Parentheses are needed. And by the way, I talked about that before in previous lessons, and you make a point right here. If you don't use parentheses, you're not writing it correctly nor doing it correctly. If you take the quantity of -3 and then you square it, you'll get 9. Okay, watch what the calculator says. You get 9. If you don't use parentheses and you just take -3 and then you square it, you'll get -9. Because the calculator knows that the exponent only applies to the number, whatever is inside the parentheses, and -3, or the negative sign, is not in parentheses here like it is above. So parentheses are important. It changes the sign of the number, so remember that. So practice good habits. So here we got -2 squared, which is -2 times -2, or 4. -1 squared, which is 1, because -1 times -1 is 1. 0 squared is simply 0. 1 squared is 1, 2 squared is 4, and 3 squared is 9. All right, so we got the order pairs. -3, 9, which we already plotted. -2, 4, so left 2 up 4. Left 1 up 1, -1, 1. The origin 0, 0. All right, 1, 1. And we see some symmetry going on here. Right 2 up 4. Right 2 up 4. It's symmetrical about this y-axis right here. So, and then 3, 3, 9. So right 3 up 9. 1, 2, 3, 4, 5, 6, 7, 8. About 9 right here. That's about 9. Okay, so let's plot. So you draw a smooth U-shaped curve. Now parabolas always get wider as they get taller, right? Or if they're going down, they get wider as they go down. So remember that. They never curve back inward. They always get wider as they get taller. All right. So we got this parabolic curve called a parabola. All right, it's called a parabola. That's what it's called. Not parabola, but parabola. And notice that it has a very certain characteristic. It goes right one, up one, and then right two, up four. All right, and then it goes right three, up nine. All right, right three, up nine. So we're going to remember those values later on. Right one, up one, right two, up four, right three, up nine. We're actually going to use those to graph functions in what's called vertex form later on. You're going to hear me talk about that a lot. Okay, but that right there is what's called the parent function y equals x squared. And all these other offspring are kind of like it, but they're either, the shape is changed depending on the value of a. The question is, how does the value of a change? Okay, a is the lead coefficient. In this case, a is 1/2. Right here, a is 1 because the lead coefficient is 1. But what happens if a gets smaller? What happens if it's 1/2? What happens to the parabola? I don't know. What we do is we check it out. Okay, so we're going to take the same domain, -3 to 3, and we're going to figure this out. But before we do, though, let me back up because I got kind of carried away right here. Let's talk about domain and range, something we have been talking about. For all these parabolas, the domain is all reals. Okay? You can substitute any real number you want in the squared. I mean, it's no big deal. You can do that. You can substitute a negative number, 0, or positive. There's no limit. So, a set of all reals. The range in this case, given that the vertex is a minimum and it's at the origin, okay, it's a minimum, which means that the smallest or the min y value, whoa, I'm going over in the other problem here, the min y value, since it equals 0, well, the range right there, all these y values, look at them, 1, 4, 9, all these y values are bigger than it, right? So y is greater than or equal to 0. The vertex is at the origin, 0, 0. It's a min because it's a low point. Low point. The axis symmetry runs right through it. Right there. You got to put the sound effects in. All right. And it's called x equals 0 because it goes through 0. So the axis symmetry is x equals 0. It's a vertical line. Okay, that's just a little review of what we've done in the prior lessons. Lessons 2 and 3. Actually, 1, 2, and 3. Okay? Okay. Now, back on to example 2. We want to learn the effects of a where it changes from 1 to 1/2. What happens when a gets smaller? Like a fraction, like 1/2, 1/3, 1/4, as it approaches 0. Well, I don't know. Let's figure it out. Well, I do know, but you need to know. So we got to do this. Okay, so what we're going to do is we're going to take 1/2 of -3 squared, and that's 1/2 of 9. Okay? Well, let me see. The -3 squared is 9. 9 times 1/2 is 9 halves. Oops, not 9/4, but 9 halves, right? 9 divided by 2 is 9 halves, and that's 4.5. Just give it a little bit more room. So left 3 up, 4.5. So 1, 2, 3, 4, and 1/2 right there. Okay, what is it when -2? So what's 1/2 of -2 squared? Well, it's 1/2 times 4, or 2. So left 2 up 2. Left 2 up 2. By the way, that reminds me. This is a video, right? So if you're sitting there in front of the screen and you're not sure what I'm talking about, and you pause it, rewind it maybe, pause, play, rewind, and use the video to your advantage. Just don't sit there and copy. All right? Pause, play, rewind. All right? Do whatever it needs to do, but go at your own pace. Go at your own pace. All right? Do that. Okay, now none of that. So let me just detail this out. -2 squared is 4. So 1/2 times 4. 1/2 of 4 is obviously 2, but if you want to divide 4 into 2, you get 2, right? So the answer is 2. That's why it's 2 right there. So what is it when -1? So 1/2 times -1 squared. Well, that's 1/2 times 1, which is 1/2. So let's plot these points. -2, 2, or apply to that. -1, half, left 1 up a half. Ooh, right there. 0. 1/2 times 0 squared, that's obviously 0. So it goes to the origin again. -1, 1/2 times -1 squared. Well, that's the same thing as above right here, right? Oh, wait a minute, wait a minute. I'm supposed to do +1. So let me see, 1/2 times 1 squared. 1 squared is 1 times a half. Well, that's a half. So 1 comma half. Write 1 up a half. Holy cow, there is the symmetry again. Look at that. These 2 points are symmetrical. Just like these 2 points are symmetrical, these 2 points are symmetrical, these 2 points are symmetrical. The same thing is happening here. So let's try 2. 1/2 times 2 squared. 1/2 times 4 is a 2. 2 comma 2, right? 2 up 2. Oh, symmetry. There's symmetry here. There's symmetry here. Okay, now let's try 3. So 1/2 times 3 squared. That's 9 times a half, or 9 halves. That's 4 1/2. So 3 comma 4 1/2, right? 3 up 4 1/2. That's right here. Symmetry there. So now let's graph the parabola. What's the difference between the two parabolas, the two parabolas? Okay. Well, let's see. If you can't tell that the second example with a equals 1/2, this is wider than x squared. If you can't tell that, well, then we'll have to overlap them. Okay, so we'll do that in a minute. The domain here, all reals. The range, well, it depends on the vertex, right? The vertex is still 0, 0, and all the y values are above it. Look at that, 1/2, 2, 4 1/2, they're all greater than that. So y is greater than or equal to 0 again. All right, vertex 0, 0. It's a min, and the axis symmetry, same, x equals 0. Why? Because the dividing line, this symmetrical line here, which is called the axis symmetry, oops, is x equals 0. Just like it was over here, it's x equals 0. It's the same thing here. It's symmetrical about the y-axis, which is x equals 0. All right. Now we're rocking and we're rolling here. Now, if you don't see that the second function is wider than the first function, we could do this. Watch this. I can take these points here on example 1 and just bring them over here. So I'll put it in red, okay? So the blue one right now is 1/2 x squared. We just plotted that, right? I take this right here, -3 comma 9, and I plot it. Left 3 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And then -2 comma 4. Left 2 up 4 right here. And then -1, 1, which is right here. And then the origin. And then all these other points. If you plot them, here we go. So here's x squared, the parent function. There it is. Let's label it x squared. There's your parent. So can't you now see that 1/2 x squared is wider than x squared? So 1/2 x squared is wider than the parent function x squared because 1/2 is a fraction, a equals 1/2. Okay, because a equals 1/2, it is less than 1. Okay, I don't know how else to say it. Obviously, 1/2 is less than 1. So we'd expect that if we see a fraction in the lead coefficient, that it gets wider versus more narrow. All right, keyword wider. Okay, so notice that, guys. Hopefully it's pretty obvious. The blue one is wider than the red one. All right, so what happens when you increase it? Not decrease it from 1 to 1/2, but increase it from 1 to 2. 2. Okay, so here a is 2. A equals 2. What happens when you increase it? Not decrease it to 1/2, but increase it. So I don't know. Let's check it out, right? Okay. So what do? Well, we evaluate it like we always do. So starting at the domain of -3. So we take 2 times -3 squared. Now notice how I use parentheses, right? Now on the calculator, if you want to use it, I'll tell you what, I'll verify it afterwards, okay? -3 squared is 9 times 2 is 18. That's how you do it in your head. 2 times 9, all right, 18. Now if you want to verify that, like we always do, You go 2 times negative 3, give it a hug, and square that puppy. Look at that. Same expression here as it is here. All right, hit the enter button. Holy cow, the calculator says the same thing. All right, you don't multiply first, you square it first. Okay, so remember that. You square first. Square first. Write that down in red. Okay, let's evaluate these points. Now, I'll evaluate them and then plot them. So negative 2, well, let's see. 2 times negative 3 squared. No, I didn't say it right. I'm being goofy. All right, I got to substitute negative 2. I already did negative 3. So negative 2 squared is 4 times 2 is 8. Oh, let's step this out. So 2, come on, Ainsworth, here we go. 2 times 4, that's 8. That's stepping it out. Evaluate on the calculator. 2 times negative 2 quantity squared. 2 times 4, better be 8. Ah, look at that, 8. Okay, negative 1. So 2 times negative 1 squared. That's 2 times 1. This is hard math, which is 2. 0. This is really hard. This is like a brain cruncher, man. 0 squared, 0 times 0. Times 2 is 0. All right, 1. 2 times 1 squared. This is hard. 2 times 1 is 2. 2. 2 times 2 squared. 4 times 2, 8. 3. 2 times 3 squared. That's 2 times 9, or 18. All right, so you see the symmetry going on here. There's symmetry here, there's symmetry here, there's symmetry here. Come on, guys. Symmetry. If you can't see it, man, look closer, take your time. All right, now let's plot. Okay, we got to plot the points. So here we go. Left 3 up 18. So there's negative 3 here, right? That's negative 1, negative 2, negative 3. So left 3 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 is right up here. So if this is 16, then 18, then 17, 18. Okay, there we go. And then left 2 up 8. So left 2 up 2, 4, 6, 8. That's an 8 right there. This is 10, 12, 14, so on. Left 1 up 2. Boy, man, this is tough, man. 0, 0. Oh, it goes through the origin. 1, comma 2. Oh, symmetrical here. Look at that. Symmetry. 1, comma 2. 2, comma 8. 2, comma 8. 2, 4, 6, 8. Oh, symmetry again. Okay. And 3, comma 18. Right? 3 up all the way up here. Okay. Symmetry. Okay. And now we plot this bad boy. So let's do that. So, you got to put the sound effects in. No, 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 no. Okay. There we go. There is y equals 2x squared. Okay? Now, if you can't see, that this one's more narrow than the other ones, then we got to overlap them, which means we got to plot the 2 other functions on this one. Okay? So let's do that. Let's plot the 2 other functions. Just for funsies here, if you can't see that this one's more narrow than the other one. So I'm going to shift to black, and I'm going to plot the parent first in black. So left 3 up 9. So left 3 up 9, right here. And then left 2 up 4, left 2 up 4 right here. Left 1 up 1 right here. And 0, 0. Whoa, what's going on there? Right here, and then 1, comma 1, 2, comma 4, 3, comma 9. So here's your parent. So hopefully you can tell right there. Woo. Hang on. There we go. Okay, hopefully you can tell that the parent function is not as steep, or what we say is narrow, as 2x squared. 2x squared is a whole lot more narrow than this one. Okay, now let's plot, I'll plot it in green. Let's plot y equals 1/2 x squared on this graph down here. So left 3 up 4.5. So left 3 up 4.5, which is right here. Okay, left 2 up 2. And then 0, 0. Whoop. Left 1 up a half, sorry. Left 1 up a half right here. And then 0, 0. And then they're symmetrical. So, whoops, that last one's incorrect. So right 2, 4, right there, right 3 up at 4.5. So here is 1/2 x squared. So you could tell that 1/2 x squared is the widest. The 2x squared is narrow. All right, or this we can say the skinniest. All right, it's narrow. This right here, x squared, there's your parent. So you can see the different effects just by graphing. Okay. Now let's fill in the rest and let's do some summaries here. The vertex on this 2x squared, well, that's the same as all the rest, right? It's 0, 0. That's not always the case. It's a minimum. You know, this is the first family. They all very similar, right? So they all have the same vertex and they're all minimums. They all have an axis of symmetry x equals 0. It's the y-axis here. All right. The axis of symmetry x equals 0 because it goes right through the vertex, which is right here, 0, 0. The domain for all these set of all reals and all these y values are above it, right? And they're all greater than or equals 0 because the min y value right here, minimum y value equals 0. And they're above it, so they're greater than it, right? Greater than or equal to. But how can you describe the effects of A? Describe the change. Okay, so here we go. When A is less than 1, it gets wider. When A is greater than 1, it gets more narrow, or what we say steeper. Okay? When A is less than 1, A is, well, okay, I'll just write it out, less than 1. When A is less than 1, whoops, less than 1, all right, greater than 0. It's a fraction between 0 and 1. Let me just write that, between 0 and 1. Between 0 and 1, not between 0 and 0, between 0 and 1. So when A is less than 1, like a fraction, okay? 1/2, 1/3, 1/4, 1/5, 1/6, and so on. All right. It gets wider. All right. The function gets wider. Parabola widens. Parabola widens. Okay, that's observation number 1. Observation number 2. When A is, let's say, greater than 1, let me spell that out in words, because I'm not sure if you guys know what the symbols are. R is greater, all right, than 1. Greater than 1. Parabola narrows, okay? Parabola gets more narrow. Gets more narrow, or what we say, steeper. Those are the two observations that you can see just within these 3 functions right here. Now let's pause for a minute and let's investigate this on the TI-83 and some other graphing software. Okay, let me show you this first. So let me show you my favorite program here. You've seen this before in class all the time. Woo. Okay, we're getting crazy now. Okay, let me expand this. Okay, so I'm going to plot a couple functions here. I'm going to plot the parent first, y equals x squared. Okay, here we go. So there's your parent right there. The question is, what happens when you change the parent to something else? So let's put another function, overlap it, okay? Let's add a new expression or a new function. Y equals 1/2 x. So y equals 1/2 x squared. What happens to it? So let's square that puppy roll right there. There we go. Okay, so you can see the one in purple is your parent. right here, this is your parent. I'm on the parent function here. The one in red is 1/2 x squared here, and you can tell it's wider, right? This is computer generated now. This is a perfect parabolic or parabolic curve, okay? You can say parabolic. That's the cool way to say it. All right, so when a goes from 1, the lead coefficient here is 1 to 1/2, it gets wider, right? Now let's do it again. Let's make a equal to 2 because we did 3 of them, right? So y equals 2x squared. Let's square this puppy dog. All right, and let's graph all 3. Now the one in blue now, here's the one in blue. The one in the blue, you could tell it's even more narrow than the parent function in purple. Let me switch the parent. Here's your parent, the one in the middle right here, the purple one, right? The blue one now is inside of it, which means it's more narrow. You can see that. So all 3 functions overlapping, you can see. So let's go back to our graph here. So this is what it looks like. Let me change something here. So right here, let me do something. This is going to be cool, man. Watch this. Only with cool technology can you do something like this. Okay, so there we go. This is a computer-generated curve of what I was talking about right here. Check that out. Look at that. So what we did in class right here is the same thing as what the computer generated. So let me annotate a little bit. Your parent function's in the middle, remember that. So right here, hang on for a second. There we go. All right. So your parent function is x squared. Inside is 2x squared. It's more narrow, so this is narrow. All right, this is your parent. And this is 1/2 x squared here, and this is wider. Why? Because the 1/2, the lead coefficient, makes it wider. And that's what I want you to learn out of this lesson here, guys, is the effects of A. What happens when A changes from 1 to 2 to 1/2? What happens when it gets bigger? What happens when it gets smaller? Okay, so there we go. That's the first thing you need to learn about the function there. The next thing you need to learn is what happens when A changes and make it negative? What happens? Okay, right, like right here. What happens when it's negative? So let's get into it. Let's go for it here. All right, so now we're going to do the same thing, but we're just going to go straight to one graph here. Right, we're just going to put them all on here. We're not going to mess around here. We're just going to go for it. We're going to pick a domain, all right, which is a set of x values from, let's say, -3 to 3 again. Why not, right? And we're going to take a look at our second parent, right? Because every family has 2 parents. You got to have 2, right? Makes sense. Here, a is equal to -1. Look at that right there. A is -1. Remember, the general function is this, a times x squared. And when the lead coefficient is negative, you know a is -1. So what happens to the graph? What happens to the parent? When that happens, okay, let's figure it out. So negative of -3 squared. And I talked about this in class, but what happens? Well, I talked about how you got to square the number first. When you square -3, you get 9, but then you got to make it negative. So this is actually -9. And if you don't believe me, well, you should, but let's do it on the calculator. Negative quantity of -3 squared. You type it in directly as you see it. Look at this. This right here is the same as this on the calculator. Hit the enter button. Whoa! You don't get +9, you get -9 because you got to square the -3 first to get 9 and then make it negative. Okay. Now watch what happens. Okay, we're going to do it a couple more times. -2. Negative of -2 squared equals, let me see, 4, then make a negative. -4. Let's do it again. Look at this. Negative of -2 squared. Okay, look at that. Boom, right there, -4. See, I'm not lying. I'm honest with you guys. I wouldn't lead you in the wrong direction. So when you take negative of -1 squared, you got to square the -1 to get 1, and then make a negative. On 0, you got to take -0 squared, which is obviously 0. 0 squared is 0. 0 times anything is 0. 1, take negative of 1 squared. You square the 1, you get 1, now make it negative. You take 2, square it, 4, make it negative, negative 4. For 3, you got to take 3 and square it, and then you got to make it negative, so you get negative 9. So let's plot these bad boys and see what happens. So left 3, down 9. So left 3 is negative 3, down 9. 2, 4, 6, 8, 9, right there. Left 2, down 4. Left 2, down 4. Left 1, down 1. 0, 0. 1, 1, negative 1. So right 1, down 1. Ooh, I see symmetry going on here. Ooh, look at that reflection right there. It's going down. Okay. Ooh, 2, negative 4. So right 2, down 4. Right 3, down 9. Right 3, down 2, 4, 6, 8, 9. Right about there. Okay, let's sketch. Okay, now let's label here. This is your parent function, negative x squared. Okay, there's your parent. What do the other guys look like? I don't know. Oh, by the way, you can even graph this. Watch this. Y equals negative x squared. Hit zoom 6. Look at the graph. Oh my goodness, look at that. It's the same. Isn't that amazing? Everything I say is actually being verified in the graph. I mean, on the calculator. Holy cow, I wouldn't lead in the wrong direction, okay? All right, so now, next one. Let's get some points. So here we go. Negative 3, so 1/4 of negative 3 squared. You square the negative 3 to get 9. Divide that by 4, you get 9/4. And that's 2 1/4. So, now let's do it a couple times. Negative 2, so 1/4 of negative 2 squared. Square the negative 2 to get 4. Divided by 4, you get 1. Negative 1, so 1/4 times negative 1 squared. Negative 1 squared is 1 times 4th is 1/4. 0, 1/4 times 0 squared, that's obviously 0. And then you repeat it. 1/4 times 1 squared, that's 1/4. 2, 1/4 times 2 squared, that's 2 squared is 4. Divided by 4 is 1. And the last one, 1/4 times 3 squared, that's 9 divided by 4, which is, we already did that above here. That's 2 1/4. Holy cow, there's symmetry going on here, here, here. Look up top. Symmetry, symmetry, symmetry. There's symmetry going on, guys. Symmetry going on. Okay, so let's figure this out. Let's plot these bad boys. All right, I'm going to do this one in blue. This one obviously is in red. Okay, so in blue, so you go left 3, down 2 1/4. So left 3, down 2, and 2, and let me see, not quite, that's 3. Back up, right about there. 2 1/4. Left 3 down, left 2 down 1. So left 2 down 1. And then left 1 down 1/4. So left 1 down 1/4. And then the origin. And then right 1 down up. Whoa. Oh my God. I gotta modify this. I went too fast. Look at this. Negative, 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 negative. These are all negative. Okay. All right. Don't do the same thing I just did. Holy cow, it's a good thing I caught this. Negative makes it probably go down. Okay. Okay. So that's one of the conclusions we're going to obviously make here. So on this one here, we go left 3, down 2 1/4. Left 2 down negative 1. So left 2 down 1. Left 1 down 1/4. Sorry, I'm going to have to. You probably were going, what in the world are you doing, Ainsworth? Because what I was saying probably didn't make any sense because there's no negative signs. All right, but there is one. So I just fixed that little mistake there. Go ahead and just make sure you understand that. That means right 2 down 1, right 1 down a quarter, excuse me, left 1 down a quarter, 0, 0, and then right 1 down a quarter. So right here. And then what's the next one? 1 comma negative 1/4, 2 comma negative 1, so right 2 down negative 1, and then 3 comma negative 2 and a quarter. There's 2 and a quarter. So there we go. So this right here is negative 1/4 x squared, and it's wider, all right, than, all right, negative x squared, which is the parent. We expect that because we learned from our previous one, when you have a fraction there, you expect it to be wider than the parent. The keyword is wider. All right. What happens when a is negative 3? So let's figure that out. Let's put this one in green, okay, just for funsies right now. So here we go. So negative 3 times negative 3 squared. 9 times negative 3 is negative 27. Negative 2. So negative 2 times negative 2 squared. You square negative 2 to get 4 times negative 3 is negative 12. Negative 1. Negative 3 times negative 1 squared. That's negative 1 squared is 1 times negative 3 is negative 3. And then 0. Negative 3 times 0 squared. Well, that's 0. That's easy. 1. Negative 3 times 1 squared. That's negative 3. 2 squared. Negative 3 times 2 squared is negative 3 times 4, which is negative 12. And 3 squared, excuse me, negative 3 times 3 squared. 9 times negative 3, negative 27. So I'm only going to plot these because, oh, you know what? Take that back. We have enough room. Okay, so here we go. We're going to plot them all. Oh, yeah. So left 3 down 27. So left 3 down, no, 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 27 right here. And then left 2 down 1. Left 2 down 1. The left 2. Okay, down 1. What happened here? Left 2. Oh, okay. Hmm. 4. Hang on. Left 2 down 12. What am I saying? Okay, so here we go. So left 2 down 12. So left 2 down 12 is right here. There we go. Left 2 down 12. Left 1 down 1/4. Left 1 down 1/4. Right about there. And then 0, 0. And then 1 comma negative 1 and quarter. Right there. 2 comma negative 1. So right 2 down negative 1. And then we've got, excuse me, 2 comma negative 12. What am I saying? 2 comma negative 12. So 2 down negative 12 right here. And the negative 1 comma, excuse me, 1 comma negative 3. Ah, okay. 1 comma negative 3. So right here. So here are the 2 points. I'm sorry. So this is going to be a challenge. Almost. Gotta put the sound effects in, man. So this right here is negative 3 times x squared. And notice that it's really narrow. Really narrow. Because it's negative, it opens down. All right, so the negative makes it open down. And the bigger value of a, the absolute value of it, that is, makes it gets really narrow. All right, so as the number gets bigger, either more positive or negative, it gets more narrow. As it gets more of a fraction, closer to 0, it gets wider compared to the parent. All right, so let's go ahead and write down the effects of A here. So first of all, first thing is, when A is negative, the parabola opens down. When A is less than 0, that means negative, guys. Negative. All right, parabola opens down. Parabola opens down. First thing, looks like this. All right. Second thing, all right, just like in the first discovery here, um, when A goes from, let's say, A equals negative, negative 1 to negative 2 to negative 3, dot, dot, dot. All right, it gets more narrow. It gets more narrow. All right. If A is a fraction, it gets wider. All right. If A is a fraction, all right, between, let's say, between negative 1 and 0, like negative 1/2, negative 1/4, and so on, all right, gets wider. Gets wider. Okay. That's all there is to it. Now remember, this is a video, right? And you could check things out again if you want. If you want to rewind it, you could use your technology. You can use your TI-83 or 84. You can use this graphing program. Watch this. If I change the A value and I make it negative, watch this. Boom. Make it negative there. Make the parent function negative. Ooh, not like that. Let's change that. Okay. Let's see if I can do this. Yeah, there we go. And I make the 1/2 negative. Watch what happens to all these parabolas. All right. They go down, right? Look at that. They go down. Why? Because the y values are now negative, so they got to be below the x-axis right here. All right. So in fact, let me clip this in. So check this out. So what I just did was this. Look at that. Okay. So I got this graph right here. You can tell. There we go. That it got wider, okay? So it went, the A value, if it's negative, it goes down versus up. Secondly, as A gets bigger and gets more narrow, as A gets to be a fraction and closer to 0, it gets wider. Once again, look at the parent values. So we got, you got your parent function in the middle. You got, in this case, this is not exactly the same because I changed the little values, but it gets wider here. Actually, let me go back. Let me see what the function, oh, so it's negative 1/2. So I choose a little bit different values, but that's okay. But you can tell that it gets wider here as you make it a fraction like negative 1/2. On blue one here, it gets more narrow if you make it negative 2. They're all negative, so it goes down versus up. That's what I wanted to talk about today. Okay, so you got your ideas here. What you need to do is just experience that, all right, and try it on your own. Do your homework, of course, and I'll see you in my next lesson here, okay? Next time, next day. This is Mr. Ainsworth. Have a good day. I'll see you tomorrow.